Hello students. In this recording, I would like to talk about an interesting topic of second PUC curriculum. Before we get into the topic, so let me give you an example. Students, take a closer look at this image. Here in a glass we have water, and in a spoon, half a spoon of salt we have taken. So this is salt and this is. And now what we will do, we will mix these two substances. This is a different substance, this is a different substance. So we'll mix salt in water and stir it well. Then we are going to get this substance. We are going to get mixture of salt and water. It results in the mixture of salt and water. But can we see salt particles in water? No, we are not able to make out where the salt particles are, because the salt particles are uniformly distributed into the solvent molecules. Correct. So that means this has resulted in uniform mixing up of two components. Since it is uniform mixing up of two components, it is a homogeneous mixture. I hope everybody knows about it. So when we mix salt and water, we get a homogeneous mixture. Similarly, we will consider one more example. Take a closer look at this image. Yes, this is copper. I hope everybody can identify it. Copper. We'll take another metal, zinc. Kindly make a note of the color. This is somewhat brownish. This is somewhat silverish. This is zinc. If these two are mixed up uniformly by melting them in hot molten state, we can mix these two substances. Suppose if we mix these two substances, what happens? We are going to get a uniform mixing up of these two metals, that is copper and zinc, to give a different substance, which is known as alloy, right? So it is an alloy of copper, that is copper and zinc, it is known as brass. Everybody is aware of it, correct? And students, observe the colors of these three substances. Copper is different color, zinc is different color, but look at the color of brass. We have got a new color due to the mixing up of uniform mixing up of zinc atoms and copper atoms. If zinc atoms and copper atoms were not mixing uniformly, if they were not mixed up uniformly, then we would have got here and there patches of this silver color, here and there patches of brownish color. But both of them have got mixed up uniformly, therefore we have got uniform color all over the surface of brass, right? So that means this is a mixture, the new substance obtained is a mixture of copper and zinc. It is a mixture of copper and zinc. And since there is uniform mixing up of these two substances or these two metals, it is also resulting in a homogeneous mixture, right? Similarly, let me give you one more example. Don't look at the road. So here we have trees and road, but everything is suspended in what? Air, correct? It is filled with air. Atmosphere consists of air, and air consists of mixture of gases, isn't it? Air consists of mixture of gases, which is also a homogeneous mixture, because everywhere we will get same amount of oxygen, whether we breathe oxygen in Bangalore or whether we breathe oxygen in Tumkur or etc. any other place, the amount of oxygen present in air will be almost same. That is because of uniform mixing up of gases. So air is also a mixture of different substances, which is also a homogeneous mixture. Now, in three examples, I was stressing upon the point about homogeneous mixture. All such homogeneous mixtures are going to be described by one common term, that is solution. A homogeneous mixture of two or more substances is called solution. I hope now you might have got what is the topic I'm going to start in this particular recording. Yes, students, in this recording we'll start a topic, an important topic of second PC curriculum, that is second chapter, solutions. So now students, let us learn more about these solutions. And before we get into the details of solutions, like types of solutions, what are the different terms used to express the concentration of solutions, etc. Let us know the importance of these solutions, in what way it is necessary for us to know more about solutions, isn't it? So let me consider few examples so that you know the importance of these solutions in our day-to-day life. Students, take a close look at this particular image. This is jewelry as well as tableware. Tableware means fork, spoon, etc. And these articles are made of one alloy, an important alloy of copper, that is German silver, right? Similarly, let me give you one more example. These are the articles made out of another important alloy of copper, that is brass. And you are very familiar with these articles which are used for puja, right? Similarly, you are also familiar with these objects or these articles, that is medals and coins. Do you know which is the alloy used generally for making coins and medals? Yes, bronze. That is another important alloy of copper. So German silver, brass, bronze, all these are alloys. What are alloys? They are mixture of two or more metals, and they are all homogeneous mixture of two or more metals, correct? German is a homogeneous mixture of copper, zinc and nickel. Brass is a homogeneous mixture mainly of copper and zinc. Bronze is a mixture of mainly copper and tin. And I have given the percentages also. You can make a note of that. Right. So that means German silver, brass, bronze, which are used to make articles like jewelry, tableware, and articles related to puja, medals, and coins, which are all very essential in our day-to-day life, isn't it? So that means they are all necessary for us, and they are all alloys, and all those alloys are what? Homogeneous solid solution of two or more metals. Let me repeat it. The articles that we use in our day-to-day life are made out of alloys like brass, bronze, German silver, and all those alloys are homogeneous solid solutions of two or more metals. So you know the importance of solid solutions now. These are all examples for solid solutions, isn't it? Right? Then, not only that, the properties and utility of alloys depend on the composition of their solid solutions. That means when you take the solid solution of two or more metals, what is the percentage of those metals present in the solution? So we need to know about the composition of these solutions in order to utilize these alloys in a better way. Because if you change the composition, their properties will change, their utility will change. Got it? Let me repeat that sentence. As the composition of solid solutions or alloys change, their properties will change, their utility will change, isn't it? So therefore, it is important for us to know about the solid solutions or in general solutions. Another important example is this one. Take a look at this. Can I identify what it is? Yes, if you go to a dentist, generally the dentist will be found associated with such cases. Yes, this is a tooth decay. It is a typical tooth decay or dental carie. We call it as dental carie. Students, do you know why it is caused? Yes, this is going to be caused due to the deficiency of fluorides present in water. So in drinking water, fluoride ions must be dissolved, and they are supposed to be present in an optimum level. So they are supposed to be present in a proper amount in water. If it is less than 1 parts per million, that means there should be some amount of fluoride ions in water. Their quantity should not exceed 1 parts per million. That is a way of expressing the concentration of solution. We will be learning more about this little later. If the fluoride ions present in water are less than 1 parts per million, then that will prevent tooth decay. That means consumption of fluoride ions dissolved in water is essential to prevent tooth decay, but that amount should be less than 1 part per million. The amount should be less than 1 parts per million. Right? So this is very important. 1 parts per million. It should be less than 1 parts per million. and we will be learning more about ppm. It is a way of expressing the concentration of solute in solution, right? Suppose if the amount exceeds, if it is present in more than 1.5 parts per million, then it's going to cause a problem known as dental fluorosis or mottling of teeth. This is the situation caused if excess of fluorides are present in drinking water, which is known as mottling of teeth or dental fluorosis. You might have seen some people having discolored teeth. That is because they're going to consume water containing lots of fluorides. That means greater than 1.5 parts per million, greater than 1.5 parts per million, it is going to cause mottling of teeth. That is discoloration of teeth. So that means fluoride ions are necessary to prevent tooth decay. But in excessive amounts, if they are present, it is going to cause dental fluorosis. So therefore, an optimum level of fluoride ion concentration has to be maintained in drinking water. Fluoride ions dissolved in water is nothing but solution. That means we need to know the amount of fluorides present in water. That means we need to know the concentration of solution of fluoride ions in water. That means we should be knowing about the concentration of solutions, isn't it? So that's how it is important for us in our day-to-day life. In addition to this, if very high concentration of fluoride ions are present in water, then it can be poisonous also. It may be poisonous if you have very high concentrations of fluoride ions in drinking water, right? And we know that in rat poisons, to kill rat and mice, we use sodium fluoride, isn't it? Ratex, which is a rat poison used to kill rodents like the mice and rats, which contains mainly sodium fluoride. Which mainly contains what? Sodium fluoride. This is what I am talking about. So that means sodium fluoride ions, fluoride, if excessive fluoride ions are present, it can be poisonous. So that means how did we get all this knowledge? By studying about solutions. What are solutions? Which are the different types of solutions? How do we express the concentration of solutions? By knowing all such terminologies or all such knowledge is going to help us in understanding such scenarios, right? So let me move on. So that means these examples are clearly indicating us that it is essential for us to know about solutions. One more example I would like to quote to know the importance. Students, you might be aware of this intravenous injections. Some injections or some medicines are going to be given into the body intravenously. That means they will be injected to the body through veins or arteries, correct? Veins. Uh, Intravenous injections are always dissolved in water containing salts at particular ionic concentrations that match with the blood plasma concentrations. That means when we take blood plasma, there are some amount of salts dissolved in it, correct? So what is the concentration of salts present in blood plasma we should be knowing. So only when we know the blood plasma concentration, then we can match that concentration in the intravenous injection. Sufficient amount of salt, a required quantity of salt must be dissolved in that medicine so that when it goes into the blood, it should not cause any variation. The concentration of injection given should match with the concentration of salt present in blood plasma. So one will be knowing that by studying about solutions. Students, all such examples are going to motivate us to know about solutions. So students, I hope now you are in a frame of mind that you should be learning more about solutions, correct? Now we will get into the details of solutions. Let us first consider some important terms associated with solution. Let me consider the same example that I had considered at the beginning, that is dissolution of salt in water, correct? So here salt, this is water. Students, you look at the amount of salt and look at the amount of water. Which is present in larger quantity? Yes, water is taken in larger quantity, salt is taken in smaller quantity. So in the resultant mixture, that is homogeneous mixture of salt and water, what we call it as solution, in that solution, we have two important components. One is salt. Here in this particular example, one component is salt, the other component is water. The component which is present in lesser quantity will be called as solute, and the one which is present in larger quantity will be called as solvent. Let me repeat that. In a solution, the component which is present in lesser quantity is called solute, and the one which is present in larger quantity is called as solvent. So here, let me make a correction over here. This is not solute. This is solvent. This is solvent. The one which is present in larger quantity is called as solvent. Mixture of solute plus solvent is known as solution. Let me do that also. Solute plus solvent will give you solution. Right. I hope you have understood. Any solution will contain these two components, that is solute and solvent. Correct. Students, depending on the number of components present in the solution, we have different terms to be used, like binary solution and ternary solutions, etc. I will tell you about that little later. And before that, let me consider one more example. This is what I was talking about. A solution which contains only two components is called a binary solution. So that means here, this is a binary solution, salt and water. Salt, one component, water is another component. Only two components, such solutions are called as binary solution. And in this particular chapter, we have to restrict ourselves only to binary solutions. What if the solution contains three components, two solutes and one solvent? Then it is called as ternary solution. What if the solution contains four components, two solutes, two solvents, or one solvent, three solutes? That is called as quaternary solution. But we will be concerned mainly about binary solution. So let us go on and learn some more terms. So let me give you one more example. Yes. Students, here we have two beakers and both of them are containing solutions. This is solution 1, this is solution 2. This is solution 1, this is solution 2. So observe this carefully and make out the difference. What difference you can make out? Here, these are the spherical particles are called as solute particles, and the other one is solvent. You can see solute and solvent, right? So now if you compare these two, this is containing larger quantity of solute particles, this is containing little quantity of solute particles, isn't it? Solution 1 is containing large amount of solute, whereas solution 2 is containing little amount of solute. Now, how do we make distinction between these two? Or when we compare these two, we can say this is containing large amount of solute, this is containing little amount of solute. To describe that, we have special terms in solutions to use. This is called as concentrated solution, this is called as dilute solution. The one which contains large amount of solute is called as concentrated solution. The one which contains little amount of solute is called as dilute solution, right? So let me repeat that. A solution which contains very little amount of solute is called a dilute solution. A solution which contains very large amount of solute is called as concentrated solution. Students, it is only a qualitative way to compare the solutions. It will not tell us about the exact amount of solute present, but still we can compare the solution. Suppose if you dissolve copper sulfate in both the solution, if you have copper sulfate in both the solutions, and we know that copper sulfate is blue in solution, the solution which contains more amount of copper sulfate will be having more intensity of blue color. The one which is having little amount of copper sulfate will be very light or having low intensity of blue color. So that's how we can say which is dilute solution, which is concentrated solution. Sometimes we also look at the color of the solution to say which is dilute, which is more concentrated. So that is only a qualitative way of telling which is containing more solute, which is containing less solute. So Let us go on and learn some more terms associated with these solutions. So now we understood what is solute, what is solvent, what is a binary solution, what is dilute solution, what is concentrated solution. Let us go on and learn some more terms. Yes, students, take a closer look at this particular diagram or image. Here, with the help of this diagram, I'm going to explain the process of dissolution of solute. During the dissolution of solute, what is the process which is going to occur, or how exactly solution will be formed, or during the formation of solution, what processes are going to occur. Students, initially, when we put salt into water or solute into water, let us say this is solute, this is solute, this is solvent. This is solvent, correct? In all the three beakers, this is solvent and that is solute. So initially, when we put solute into solvent, what happens? The solute particles tend to go into the solution as individual ions. Correct? When we put sodium chloride into water, it tends to become Na plus ions and Cl minus ions. Right? Similarly, here also, the solid particles tend to go into the solution. They become individual particles, they get dispersed between the molecules of the solvent. That is the initial process, and that is known as dissolution. That process is known as dissolution. What is that known as? Dissolution. So initially, the process of dissolution will be faster, or the rate of solute particles going into the solution will be more. But after some time, some of the solid particles will come back. Solid particles will come back and deposit as solid solute. You can see over here. Some of them are going back, right, into the salt. That is called as crystallization. Solid particles going into the solution is known as dissolution, and solute particles coming back and getting deposited as solid solute is known as crystallization, right? So crystallization, that is another important term. But initially the rate of dissolution will be greater than rate of crystallization. That means number of particles going into the solution is more than the number of particles coming into the solution. You can compare the arrow marks. There are 3 arrow marks wherein the solute particles are going into the solution. Only 1 arrow mark showing the solute particle getting deposited as solid. So rate of dissolution is greater compared to rate of crystallization initially. As the time goes by, the number of particles going into the solution decreases and the number of particles coming and depositing as solid solute increases. That means rate of dissolution becomes equal to rate of crystallization, and that state is known as equilibrium state. Equilibrium. I hope you have heard of this term. So this is known as equilibrium. Now the solution is at equilibrium, you can see, right? So when the solution is at equilibrium, or by the time equilibrium is achieved between dissolution and crystallization, how much of solute has gone into the solution is going to decide the solubility of the solute. Let me repeat it. By the time equilibrium is achieved between dissolution and crystallization, how much of solute or salt has gone into the solution will decide the solubility of the salt. So what is solubility? Another important term associated with solutions, that is solubility. The maximum amount of solute that can be dissolved in a specified amount of solvent at equilibrium is called solubility of a substance. So to understand the meaning of solubility of a substance, I had to explain all this, and it is very important as well. You also come across the terms dissolution and crystallization, right? So how much of solute can go into the solution by the time the solution achieves equilibrium? That is the amount of solute that can be dissolved in the solvent at that particular temperature. This solubility depends on, solubility of any substance in any solvent depends on the nature of solute, nature of solvent, temperature, and also pressure. Solubility of a substance depends on nature of solute, nature of solvent, temperature, and pressure. Nature of solute and solvent. For example, if you dissolve sodium chloride in water, it dissolves. More amount of sodium chloride can be dissolved in water. But same sodium chloride, if you put it into ethanol or kerosene, it doesn't dissolve at all, right? So you can compare the solubility of substance in one solvent with the other solvent, correct? So sodium chloride or common salt can be dissolved in water. More amount of sodium chloride can be dissolved in water, where very little or no amount of solute can be dissolved in the organic solvent like kerosene or ethanol. So that depends on the nature of solvent used. Similarly, nature of solute. If you dissolve camphor in ethanol, it dissolves. If camphor, if you put into water, it doesn't dissolve. So the solubility of a substance depends on what is the solute, what is the solvent. Generally, polar solutes, that you should remember. Polar solutes, that means which have got ions, dissolve polar solvents like water. Polar solvents means which have polarity in the molecule, partial negative charge, partial positive charge, negative charge. Similarly, non-polar solutes like camphor, non-polar solutes dissolve non-polar solvents. Correct. So that is another important point. Next, temperature. The solubility of a substance depends on temperature. Take some amount of water in a beaker, about 50 ml, put some salt, common salt into that, dissolve it properly, and then add some more, dissolve it. You will reach a stage where some solute will remain, some salt will remain in the beaker. Then what you do is you heat it. You boil the solution, even that undissolved salt will also dissolve. That means as you increase the temperature, solubility of the substance, generally solubility of solids in liquids increases. That depends on the nature of solute as well. And pressure generally is going to affect the solubility of gases in liquids. Pressure will not affect the solubility of solids in liquids, but pressure will definitely affect the solubility of gases in liquids. Solubility of gases in liquids and associated with that Henry's law, all that we will consider, and we will learn all that in detail as we proceed in the class. Okay. Next. So solubility, we understood the meaning of solubility. We also understood what are the factors that affect solubility of a substance. And let us move on. And depending on this solubility, we have three different types of solutions. One is saturated solution, the other one is unsaturated, the other one is supersaturated solution. First one, a solution in which more solute can be dissolved at the same temperature is called unsaturated solution. That is, you take a beaker, add some salt, stir it well, it dissolves. You add some more, stir it well, dissolves. That means even if you add some more, it will dissolve. You know that. That state of the solution is known as saturated state, unsaturated state. That means a solution in which you can dissolve some more salt is known as unsaturated solution. It is like you will be very hungry. You will be eating food. You will eat 2 chapatis. But still you have the feeling that you can eat 2 more chapatis. That means you are still unsaturated. But if you, after eating 5 chapatis, you will feel that I cannot eat any more chapatis. That is saturation. Correct? It is saturated. Your hungriness is saturated. Similarly, solution, the amount of solute that can be dissolved in a solution, if it is there, that means a solution, if it can dissolve some more salt, that is known as unsaturated solution. A solution in which you cannot dissolve any more salt, where you cannot eat any more food, that is called a saturation point or saturated solution. A solution which no more solute can be dissolved at the same temperature and pressure is called saturated solution. Saturated, right? And one more term associated with this is supersaturated solution. Supersaturated solution is the solution which contains more solute, then it would be necessary to saturate it, right? So to saturate you, 5 chapatis are enough, correct? If you eat 5 chapatis, that is enough for you, but forcefully you will eat another half chapati, that is super saturated, correct? Here also, if you dissolve 10 grams of solute in a solvent, suitable solvent, that is saturated level, but you will add 10.5 grams into that, that 0.5 grams will almost remain undissolved, that is called as super saturated solution. So let me repeat. Based on solubility, we have saturated solution, unsaturated solution, and supersaturated solution. And you should understand the meanings of all this. The solution in which more solute can be dissolved at the same temperature is known as unsaturated solution. Right? If you are dissolving salt after heating, that is not saturated solution. Right? You take a beaker, add salt, dissolve it, salt dissolves. Add some more salt, salt remains. That is not saturated, unsaturated solution. After adding some more salt, it should be dissolved. And you will be knowing that if you add little more also, it will dissolve. That is called as unsaturated solution. It is like, you know that you can eat one more chapati. That is unsaturation. A solution in which no more solute can be dissolved at the same temperature and pressure is called as saturated. And supersaturated solution is one which contains more solute than it is required to saturate that solution. Students, this is about the solubility and types of solution based on solubility of the solute. And based on solvent used, we have different types of solutions. If you are using water as the solvent, we call it as aqueous solution. Aqueous solution. What is aqueous solution? A solute dissolved in water. If the solvent used is other than water, like benzene, ether, etc., that is non-aqueous solution. Non-aqueous solution. That is very important, because if you go to organic chemistry, we say aqueous potash, alcoholic potash. Example, aqueous potash. Aqueous potash means potassium hydroxide dissolved in what? Water. Potash means KOH. Aqueous potash means potassium hydroxide dissolved in water. But same potassium hydroxide, if you dissolve it in alcohol, ethanol, we call it as alcoholic potash. Right? And these two reagents are totally different. They are going to bring about totally different types of reactions. That is why we should be very careful. Aqueous potash, if you use, it is going to undergo substitution, nucleophilic substitution reaction, give corresponding alcohols with alkyl halides. When you treat an alkyl halide with aqueous potash, it will give alcohol by nucleophilic substitution. If you treat same alkyl halide with alcoholic potash, then dehydrohalogenation will take place to give alkenes. So that just by changing the solvent, properties will change, types of reactions will change, nature of products will change. That is why you should be very, very careful. So if a solution is prepared in water, aqueous solution. If solution is prepared in any other solvent other than water, it is known as non-aqueous solution. I hope you understood that. Let me repeat one more time. A solution can be aqueous or non-aqueous depending on whether the solvent is water or any other solvent. Now students, we have understood different types of solutions. We understood dilute solution, concentrated solution. We understood saturated, supersaturated, and we understood aqueous, non-aqueous, and we also understood binary solution, ternary solution, etc. Now let us summarize the types of solutions. Yes, we have different types of solutions as we have already discussed. Based on the number of components present in the solution, we have binary solution, ternary solution, quaternary solution. Binary solution in which contains only two components, that is one solute, one solvent. What is ternary solution? Ternary solution which contains three components two solutes, one solvent, or two solvents, one solute. That is ternary solution. Similarly, quaternary contains four components. So it goes on. Generally, we deal with binary solutions. In this chapter, particularly, we'll be dealing with binary solutions. The other type that we discussed is based on the solubility, based on the amount of solute that can be dissolved in a solution, or that is dissolved in a solution. We have saturated, supersaturated, and unsaturated solution. Saturated solution is that in which no more solute can be dissolved at the same temperature and pressure. Unsaturated solution is one which you can dissolve some more salt in it at the same temperature, right, and pressure. Supersaturated solution which is one which contains more amount of solute than it is required to saturate that. That means you eat more than what you require. That is known as supersaturated solution. So a solution is containing more solute than what it can. That is called as supersaturated solution. Similarly, we also classified solutions as dilute and concentrated based on the amount of solute present in the solution. If the solution contains very little amount of solute, we call it as dilute solution. If solution contains very high amount of solute or large quantity of solute, concentrated solution. Then based on the solvent, we have aqueous solutions and non-aqueous solutions. Aqueous solutions are those which contains water as the solvent. Non-aqueous solutions are those which contain any other solvent other than water as the solvent. Students, apart from this, we also categorize solutions as acidic, basic, neutral, based on the pH of the solution. The solution can be acidic or basic or neutral based on pH of the solution. That we will be dealing in some other chapter. So this is about the types of solutions. So now let us consider our discussion only to binary solutions. Now we will consider mainly binary solutions. So our aim is to deal mainly with binary solutions. Now let us consider some different types of binary solutions. Types of binary solutions. Students, we classify binary solutions depending on the solvent into three different categories. If gas is, let me type it, we have gaseous solution, we have solid solutions, we have liquid solutions. Gaseous solution, solid solution, liquid solution. Gaseous solution, gas is the solvent. Gas is the solvent. For solid solutions, solid is the solvent. Solid is the solvent. And liquid solution, liquid is the solvent. Liquid is the solvent. So based on which is the solvent, whether gas is the solvent, liquid is the solvent, solid is the solvent, we have three different types of binary solutions: gaseous solution, solid solution, and liquid solution. And let us discuss about these gaseous and solid and liquid solutions with examples by considering a table. So I'll put a table on the screen. Observe the table carefully, which will give all the information related to that. Yes, students. So first we have gaseous solutions. For gaseous solutions, what is the solvent? Solvent is gas, correct? And in gaseous solutions, we can have gas as the solute, liquid as the solute, solid as the solute. For a gaseous solution containing both the components as gases, the example is mixture of gases. Air is the best example, oxygen, nitrogen. Air is the example for gaseous solution containing gas and gas, or gaseous solution containing gas as the solute. Gaseous solution containing liquid as the solute. Example, chloroform mixed with nitrogen gas. So nitrogen is the solvent, chloroform is the solute. Similarly, gaseous solution containing solid as the solute particle, camphor dispersed in nitrogen gas. Again, nitrogen gas is the what solvent medium, and camphor is the solute. And if you take up liquid solutions, liquid is the solvent, and when the solvent is liquid, it again can contain gas as the solute, liquid as the solute, solid as the solid. For a liquid solution containing gas as the solute, example is oxygen is the solute dissolved in water. Water is the solvent. So it is a liquid solution containing gas. Similarly, a liquid solution containing liquid as a solute, ethanol mixed in water, methanol mixed in water, kerosene mixed in ethanol, right? Chloroform mixed in ethanol, carbon tetrachloride mixed with ethanol, like that. Then a liquid solution containing solid as a solute, glucose dissolved in water, salt dissolved in water, right? Any salt dissolved in water, they are all examples for liquid solution. Generally, we will be coming across with liquid solutions. And of course, we are also learn in detail about gaseous solutions in this particular chapter. And solid solutions generally deal with alloys. We will be having very brief discussion about it. Mainly we will be dealing with gaseous solution and liquid solutions. Solid solutions are those which contain solid as the solvent. Solid as the solvent. A solid solution containing gas as solute, that is hydrogen in palladium. We say adsorption of hydrogen in palladium, we say, correct? Let me type the term because it is relevant here. Adsorption of H2 on palladium. So we come across this term in chapter number 5, that is surface chemistry. Adsorption of hydrogen gas and palladium. Palladium, you have to write small d. Right? Palladium. So when we take palladium, it is a d block element. There will be interstitial spaces. Hydrogen gas molecules get accumulated into those interstitial spaces. That means interstitial spaces present in the crystal lattice of palladium is capable of holding on more amount or more volumes of hydrogen gas. That is called adsorption of hydrogen gas or occlusion of hydrogen. And we will be studying about this in d block elements once again. And we will be studying about adsorption in surface chemistry. And this is the example for solid solution containing gas as the solute. Similarly, you can have what? Gaseous solution, solid solution containing, let me consider the pen. Yes, solid solution containing liquid as the solute, amalgam of mercury with sodium. Any metal in combination with mercury is known as amalgam. Sodium plus mercury, sodium amalgam. Sodium plus zinc, mercury plus zinc amalgam, like that. So amalgams, sodium amalgam, zinc amalgams are the examples for solid solutions. Solid solution containing liquid as the solute. Solid solution containing solid as a solute, example alloys, copper dissolved in gold, zinc dissolved in copper, brass alloy, bronze alloy, German silver. They are all examples for solid solutions containing solid solute and solid solvent. The one which is present in larger quantity will be called as solvent. The one which will be present in lesser quantity will be called as solute. So this is about different types of binary solutions. Now students, let us go on and learn more about the solutions. So this is where we have finished the types of binary solutions. Now we'll get on to another important term associated with solutions. Students, take a closer look at this particular image. We have 3 test tubes over here. All the 3 test tubes are containing copper sulfate solutions. In all the 3, we have filled copper sulfate solution. But Is there a difference between all the three different test tubes? Yes, they are looking different. This is looking more intense. The blue color is more intense here. This is looking very light in blue. The intensity of blue color is very less here, more here. Correct. Why is that? Can you think of why is that? Because this test tube, first test tube is containing more amount of copper sulfate. The last one is containing very little quantity of what? Copper sulfate. So to describe how much of solute is dissolved in a specified amount of solvent, here in all the three test tubes, amount of solvent is same, but the quantity of solute present in them is different. That is why different colors. As the amount of copper sulfate dissolved changes in the same volume of water, the intensity of color also changes. Here the intensity of color is clearly indicating us that they are all containing different quantities of solutes. Correct? So the term that we use to describe the quantity of solute present in a specified amount of solvent is known as concentration of solutions. So what is the term that we use? Concentration. What is concentration of solution? It is the amount of or quantity of solute present in a specified amount of solution. So concentration of solution helps us to predict uh, the amount of solute present in any given solution. And concentration of any solution can be described in two different ways. Concentration of solutions can be described in two different ways. One is qualitative method and the other one is quantitative method. Concentration of solutions can be described in qualitative method as well as quantitative method. What is qualitative? What is quantitative? So just to understand or make you understand that term very easily, I can give you one example over here. Suppose if your mother is cooking something in the kitchen, sitting in the hall, you can predict what she is cooking, right? So you will tell, yes, mother is cooking so and so food. Why? Because you can smell it. By smelling that food, you can say what food is cooked. That is only qualitative way of analyzing. But if you take that food in a plate and eat some amount, then it is quantitative. So what food is cooked in the kitchen, if you guess, that is qualitative. If you eat some amount of that food, then it is quantitative. Got it? Similarly, here also, qualitative method will only tell you which is more, which is less. But quantitative will tell the exact amount of solute present in the solution. So here, qualitative, we can say, we can compare the solution, you can say which is more concentrated, which is less concentrated. So the solution which containing more amount of solute is called as concentrated solution. The one which is containing very little quantity is called as dilute solution. In quantitative method of expressing concentration of solution, we can only say which is more concentrated, which is less concentrated with respect to one another. It is only comparative nature. That will not give the exact idea about the amount of solute present in the solution. To get an idea about the exact amount of solute present in the solution, we need to use quantitative method of expressing concentration of solution. Under quantitative method, we use different units or different terms to express the concentration of solutions. Let me tell you one by one. Under quantitative method, we use terms like this: mass percentage, weight by weight. Mass percentage, weight by weight. Second one is volume percentage, volume by volume. Third one is mass by volume percentage or weight by volume percentage. We also say weight by volume percentage. Then we have parts per million, ppm, parts per million, ppm. Then we have mole fraction. This is the symbol used to express mole fraction. We say chi, chi is the symbol used to express mole fraction. Then we have another important term called as molality. Molality, small m is the symbol used to describe molality. And last one is molarity. Molarity, capital M. These are the most commonly used terms or units to express the concentration of a solution quantitatively. And when you express the concentration of a solution by any of these methods, then that solution is known as standard solution. What is that solution known as? Standard solution. Let me type that. Standard. What is a standard solution? A solution whose concentration known is called as standard solution. For any solution, if you specify the concentration by any of these methods, that is called a standard solution. In the laboratory, you might have done experiments. They will say 1 molar HCl solution. They will say 0.1 normal NaOH solution, 0.1 molar acetic acid solution, etc. In addition to these terms, we also use normality, but in NCERT syllabus now this term is not being frequently used. Another term, normality, that is also another important way of or method of expressing the concentration of a solution. We will deal with normality particularly with reference to competitive examinations, but generally in theory we are not associated with normality. Generally we will be using molarity, right? So now these are the different terms which we have to learn in detail. Each one of these we have to consider. We should write down the formula. We have to solve 1 or 2 problems based on each of these terms, right? Now students, let me just consider the first one and then stop the discussion in this recording, and we will consider the remaining terms in the next video. I mean next recording. Next, mass percentage. Let me quickly consider mass percentage. Mass percentage, weight by weight. So to calculate mass percentage of any component, we can use this formula. Mass percentage of a component is equal to mass of that component multiplied by 100 divided by what? The total mass of the solution. So to calculate mass percentage, you should know the total mass of the solution. You should know the mass of the component. Then you can easily calculate the mass percentage. So this is the formula that we use to calculate mass percent of a component in a solution. Mass percentage of a component is equal to mass of the component in the solution multiplied by 100 divided by total mass of the solution. And students, to understand the meaning of this much better, let me consider an example. 10% glucose in water by mass. What is the meaning of this? 10% glucose in water by mass, or in the problems they might also give like this. They'll give 10% glucose solution, 10% glucose bracket aqueous AQ, that means dissolved in water, aqueous solution, bracket you have weight by weight. This is what they'll give. So the meaning of this is 10 grams of glucose, 10 grams of glucose plus 90 grams of water, so that the mass of the solution is equal to 100 grams of the solution. Right? 10% glucose aqueous solution weight by weight, or 10% glucose solution in water weight by weight, or 10% glucose in water by mass. Meaning of all that is 10 grams of glucose dissolved in 90 grams of water, so that you get 100 grams of the solution. That is the meaning of that, right? So if you substitute in this, mass of what glucose is 10, you substitute over here as 10 grams into 100 divided by total mass of the solution is how much? 100 grams. 100 gram, correct? So 10 into 100 is 1000, divided by 100 is 10. So we got the answer as 10% solution, isn't it? So 10 into 100 is 1000, divided by 100 is 10% glucose you'll get. So that is the meaning of that, right? So let me repeat that one more time. 10% glucose solution means 10 grams of glucose dissolved in 90 gram of water, resulting in a 100-gram solution. Students, generally we use such methods, that is mass percent weight by weight, in industrial applications. Chemical industries, we use this method. And example also I'll give. It is commonly used in industrial chemical applications. For example, commercial bleaching solution contains 3.62 mass percentage of sodium hypochlorite in water. That means if you take 100 grams of sodium hypochlorite solution, 3.62 grams of sodium hypochlorite is present, remaining is water. Sodium hypochlorite is a very good bleaching agent, a bleaching solution. So generally we make use of this term in chemical industries, right? So let me quickly solve a simple problem based on this and then stop the discussion in this recording. Calculate the mass percent of the solution obtained by dissolving 20 grams of sugar in 480 grams of water, right? How do you do it? As usual, you have to apply the formula mass percentage of a component is equal to mass of the component in the solution into 100 divided by total mass of the solution. So very simple. According to the formula, we will do it. Mass of the component in the solution is how much? This is equal to mass percentage of the component is 20 grams. 20 grams into 100, correct? Into 100 divided by total mass of the solution. Here, this is where students will do mistakes. Total mass of the solution is 480 plus 20. So that is total mass of the solution. 480 plus 20. Mass of solute plus mass of solvent is equal to mass of the solution. So 480 plus 20 is 500. Correct. So 2 zeros get cancelled. Then you have 20 divided by 4, that is equal to 20 divided by 5, that is equal to 4%. So answer for this simple question is 4%. Students, I hope you have understood it. So let us continue the discussion in the next recording. I will be continuing from the next, that is volume percentage, volume by volume. I'll continue from there. And before that, let me I'll be recalling few points and then I'll be moving forward. Students, as and when the topic is completed, you should go through the NCERT exercise, solve questions. That is where you'll get more confidence. I hope you'll all do that. Thank you.